Built as Canada's first jet fighter, the Avro Canada CF-100 Canuck was an all-weather interceptor developed to defend against Soviet bomber threats during the early Cold War, and would prove to be the only Canadian fighter to enter mass production and operational service, wherein it worked as a reliable and capable aircraft in the harsh northern environments. However, the CF-100 was also very much a product of its time, with its straight-wing design barring it from supersonic-level flight, while it also proved to be technically conservative when compared to the emerging swept-wing fighters, though in frontline roles it exceeded expectations and served effectively with the Royal Canadian Air Force and its NATO allies, thus securing its place as a crucial, if transitional, asset in Canada's air defence strategy. The CF-100 story goes back to the final years of World War II, when Canadian policymakers came to a firm conclusion that the nation could not afford to rely entirely on foreign powers for its military aviation needs, with there being a growing awareness that national security required more than just operational capability, but instead demanded technological autonomy. Canada's vast geography, sparse population, and proximity to the Arctic and North Atlantic meant that a credible air defence system would be vital in any future global conflict, with rapid advances in aerospace technology, particularly in the field of jet propulsion, making it clear that future air combat would bear little resemblance to the dogfights of the recent war. And in order to remain relevant and self-reliant, Canada would need to invest in its own aviation industry. As early as July 1944, with the war still raging, Canada began developing its own turbojet engine, a bold move that placed it among a small group of nations actively pursuing jet propulsion, with the result being the Avro Canada Canuck, an experimental engine that, while never seeing operational use, marked an essential first step in cultivating domestic expertise in jet technology. The Canuck program itself was proof of principle, demonstrating that Canadian engineers and manufacturers could enter this new technological domain and hold their own, while it also laid the foundation for a deeper partnership between the government and the newly formed Avro Canada, which would soon take on far more ambitious projects. By January 1945, the Royal Canadian Air Force issued a formal requirement for a twin-engined, radar-equipped, all-weather interceptor, with this specification requiring any new aircraft to have to fly long distances, function reliably in harsh conditions, and detect enemy aircraft regardless of weather or time of day, with there being no aircraft in existence at the time to meet these demands, and none were in development that showed promise of doing so. Therefore, on November 3, 1945, an agreement was signed to begin the development of a new interceptor, and less than a year later, in October 1946, the Canadian government awarded development contracts to Avro Canada, with the aircraft design effort, now operating under the designation XC-100, being a national priority, and was initially overseen by Edgar Atkin, Avro's chief engineer, though the project was soon passed to John Frost, a British aeronautical engineer recently brought over from de Havilland. Frost, together with Avro's chief aerodynamicist Jim Chamberlain, undertook extensive redesign work, reshaping the fuselage and refining the aerodynamics to meet the unique demands of high-altitude all-weather interception, while on May 17, 1949, a further agreement expanded the CF-100 program to include the production of 10 pre-production aircraft and 30 examples of the Avro Orenda turbojet, a wholly Canadian engine that evolved from the Canuck initiative. The development of the CF-100 was indeed prudent, as despite World War II having ended in 1945, the wartime alliance with the Soviet Union quickly disintegrated, giving way to a climate of suspicion, espionage, and arms races that were characterized the Cold War, with the detonation of the first Soviet atomic bomb in 1949 and the outbreak of the Korean War in 1950, adding urgency to Western defense preparations. In Canada, these events prompted a major reallocation of resources towards national defence, and between 1951 and 52, the RCAF received 46.6% of the entire defence budget, an extraordinary share that underscored the perceived importance of maintaining air superiority in the North American theatre, while concurrent civilian projects such as the C-102 jetliner, the world's second flying jet airliner after the British de Havilland Comet, was scrapped despite promising market forecasts in order to make way for more asset allocation to the CF-100. The CF-100 was engineered from the ground up to suit Canada's strategic environment, with its twin-engine configuration providing reliability in remote and unforgiving terrain, while the onboard radar and fire control systems allowed it to detect and engage enemy aircraft in total darkness or poor weather. And while it was not the fastest aircraft of its generation, the Canuck offered an impressive rate of climb and exceptional endurance, making it ideally suited for long-range patrol and rapid response. Development of the first prototype, 18101, was completed in 1949 at the Avro Canada facility in Malton, Ontario, with the aircraft being finished in an all-black gloss paint scheme adorned with bold white lightning bolts that trace the length of its fuselage and engine nacelles, while for power, the CF-100 Mark I was powered by two British-made Rolls-Royce Avon RA3 axial flow turbojet engines, each generating 6,500 pounds thrust. On January 19, 1950, the CF-100 took to the air for the first time from Malton, with squadron leader Bill Waterton at the controls, Waterton being an experienced test pilot seconded from the Gloucester Aircraft Company in Great Britain, and had been chosen precisely because Avro Canada's own test pilots lacked comparable experience with high-performance jets at the time. Encouraged by the performance of the first aircraft, Avro proceeded with the construction of a second prototype, 18102, which made its first flight in July 1950, and although it closely resembled the first, its flight test program was intended to explore additional aerodynamic configurations and evaluate structural behavior under various loads. Tragically, this phase ended in disaster on April 5, 1951, when 18102 was lost in a fatal crash that claimed the life of test pilot Bruce Warren, and though the precise cause of the accident was never fully confirmed, it was widely suspected that a catastrophic structural failure had occurred, possibly linked to the oxygen system or wing integrity. The incident had immediate and far-reaching consequences, and confidence in the CF-100 program was shaken, with serious doubts being cast over Avro Canada's engineering processes, while the project, which had until then maintained political and public support, suddenly faced intense scrutiny and was temporarily halted. In the wake of the crash, Avro Canada was compelled to undertake a thorough internal review, with several members of the original design and engineering team being dismissed, and a new task force was assembled to assess and rectify the identified weaknesses, with one major concern centering on the wing structure, which exhibited excessive flexing under stress, with this flaw, if unaddressed, potentially leading to fatigue and eventual failure. Fortunately, the fix required was relatively straightforward and could be implemented on aircraft already built or under construction, with the solution being to reinforce key structural elements to increase durability without compromising flight characteristics. While the investigations were underway, Avro was also transitioning from reliance on imported engines to a fully domestic power plant solution, and while the Mark I prototypes had been fitted with British Avon engines, the long-term plan had always involved the integration of the Canadian-designed Orenda engine, with the Orenda offering comparable and eventually superior performance, while ensuring that Canada would no longer be dependent on external suppliers for such a critical component. However, the development of the Orenda itself was delayed by a series of technical issues and production bottlenecks, with these setbacks further slowing progress and adding to the frustration already brewing in government circles. And in order to salvage the project and see it delivered to the Royal Canadian Air Force, Cabinet Minister C.D. Ho intervened decisively, ordering Avro to suspend all other work and concentrate exclusively on the CF-100. Meanwhile, in 1950, well before the testing was completed, the RCAF placed a production order for 124 examples of the CF-100 Mark III variant, and after extensive trials and further refinements, the Canuck officially entered RCAF service in April 1953, with its initial operational deployment assigned to No. 445 Squadron. The CF-100 Mark III became the first production model to equip frontline units, and was powered by two Avro Orenda 8 turbojet engines and featured a Hughes APG-33 radar system housed in the nose, while its armament consisted of 8 50 caliber Browning machine guns mounted in a removable tray beneath the fuselage, though one notable shortcoming of the CF-100 was its limited engagement envelope, particularly as Soviet threats evolved. Responding to the need for greater firepower and enhanced interception capability, Avro developed the CF-100 Mark IV, a significantly improved version based on the Mark III airframe, with the prototype flying on October 11, 1952, and introduced several upgrades, most notably a redesigned nose to accommodate larger and more powerful APG-40 radar systems, which greatly improved target acquisition and tracking. The wings were also modified to carry wingtip rocket pods, each capable of launching up to 29 2.75-inch folding fin Mighty Mouse aerial rockets, with production of the Mark IV beginning in 1954, and the final 54 airframes from the original Mark III order were converted to this new standard, with total assembly for the Mark IV, including both the Mark IV-A and Mark IV-B subvariants, eventually reaching 510 aircraft, with the Mark IV-B introducing the more powerful Orenda 11 engines, delivering improved thrust and climb performance. In a key milestone for Canadian aviation, on December 18, 1952, test pilot squadron leader Janusz Zurakowski flew the Mark IV prototype to Mach 1 in a controlled dive from an altitude of 30,000 feet, marking the first time a straight-wing jet aircraft had reached supersonic speed in controlled flight, and underscored the aerodynamic robustness of the CF-100's design. The final operational variant, the CF-100 Mark V, entered production in 1955, with this version being tailored for high-altitude interception missions and featured extended wingtips, a larger tailplane, and a complete removal of the gun armament in favor of exclusive reliance on rocket weaponry, with the Mark V being powered by Orenda 11 engines, with some later aircraft upgraded to Orenda 14s, while plans for the Mark VI variant, equipped with Sparrow 2 missiles and afterburning Orenda 11 IR engines, were proposed as an interim solution, but never advanced beyond the concept stage. However, even before the CF-100 prototype had even completed its maiden flight, engineers at Avro, Canada were already engaged in conceptual work aimed at pushing the aircraft's capabilities beyond its original design, with the Royal Canadian Air Force anticipating the need for a more advanced all-weather interceptor capable of higher speeds and improved combat performance, seeking options for future development. Recognizing the aerodynamic limitations of the CF-100's relatively thick, straight wing, Avro's chief designer, John Frost, began to investigate a range of modifications that might offer improved high-speed flight characteristics, with his proposal centered around a significant aerodynamic overhaul, including the introduction of a thinner swept wing, a feature increasingly favored in jet aircraft due to its beneficial impact on transonic performance. By December 1950, the Avro Aircraft Design Office had committed to a formal redesign initiative, using the CF-100's existing early-stage fuselage as a base, with this redesign effort being originally labeled the C-100S, though it was soon rebranded as the CF-103, with the intention behind the CF-103 being to bridge the technological gap between the operational CF-100 and the much more advanced design project that was being considered concurrently, known as the CF-104. Frost regarded the CF-103 as a pragmatic interim solution, and one that could be delivered relatively quickly, while offering incremental improvements over the CF-100, with the CF-103 incorporating a series of aerodynamic refinements, with its most visually distinctive change being the adoption of a near-delta wing, which featured a 42-degree sweep along its leading edge, and a reduction in both wing thickness and chord. These changes were intended to improve airflow at high subsonic speeds and reduce drag as the aircraft approached transonic conditions, while the tailplane and vertical stabilizer were also swept to complement the new wing design, with one design variation also exploring the integration of streamlined external fuel tanks into the leading edge of the wings, placed near the three-quarter span position, with these tanks being intended to provide additional range without compromising the aerodynamic profile of the aircraft. Despite these refinements, the performance forecast for the CF-103 remained underwhelming, as even with the proposed upgrades to the propulsion system, including the use of twin Orenda 17 afterburning turbojet engines, the aircraft's projected maximum speed in a dive was Mach 0.95, which represented only a marginal improvement of the CF-100 Mark II and Mark III, which were placarded at a limit of Mach 0.85. Such a narrow gain did not justify the cost and effort of introducing a new airframe, particularly one that retained much of the structural bulk of its predecessor, though regardless, the Canadian Department of Trade and Commerce moved forward with an order for 2 flight test prototypes and a static test article under the CF-103 designation. By mid-1951, engineering designs had been completed, and the production of jigs and tooling was well underway, with a full-scale wooden mock-up being assembled, while separate components, including a framed cockpit and engine section, were built for study, and wind tunnel testing was conducted at Cornell University and completed in November 1951. The results confirmed that the design offered no clear path to supersonic capability and highlighted the limited performance envelope of the aircraft, while 2 variations of the tail assembly were trialed during mock-up construction, with one version featuring only a mildly swept leading edge, while the second had a more pronounced rake. Technical hurdles also persisted in the power plant department, with the Orenda 17 engines intended for the CF-103 being still in a developmental stage, particularly the hybrid configuration that combined the Orenda 8 compressor, the Orenda 11's 2-stage turbine, and a prototype afterburning system, with the engineering for integrating this system into the CF-103 having not yet been finalized, leaving a significant gap in the aircraft's projected capability. Compounding these issues further was the fact that, under test, it was proven that the CF-100 had untapped potential that narrowed the gap between itself and the CF-103 in terms of performance, and as a result, the development team's interest began to shift towards more ambitious future designs, rather than investing further in what was increasingly seen as an underwhelming stopgap. Although the CF-103's maiden flight had been originally scheduled for the summer of 1952, delays pushed this to mid-1953, though by this time, the rapidly escalating Cold War had sharpened focus within Canadian defence planning, and the government insisted that resources be redirected towards the ongoing production and improvement of the CF-100, which was already proving itself a capable frontline aircraft, leading in December 1951 to the CF-103 project being formally cancelled, with the wooden mock-up remaining at Avro's experimental facility for some time before being scrapped shortly thereafter. Had it gone into production, the CF-103 would have featured a two-person crew seated in tandem under a long canopy, and would have been powered by two Orenda 17 engines, each capable of delivering 7,275 pounds thrust in dry conditions and up to 8,490 pounds with afterburner engaged, with performance figures estimating a maximum level speed of 647 miles an hour, translating to roughly Mach 0.85, with the never-exceed dive speed pegged at Mach 0.95, while the armament concept centered around a ventral gun pack housing 8 50-caliber Browning M3 machine guns, each with a 200-round ammunition load. Back with the CF-100, between 1950 and 1958, Avro Canada produced a total of 692 aircraft across all variants, and it entered frontline service in July 1952 with No. 3 Operational Training Unit stationed at North Bay, Ontario, with its operational peak in the mid-1950s, seeing 9 RCAF squadrons employ the Canuck, primarily patrolling Canadian airspace to intercept and deter potential Soviet bombers flying over the Arctic. Among RCAF aircrew, the Canuck earned a mixed reputation, with its reliability and ruggedness being well respected, but its flight characteristics led to less flattering nicknames. It was often referred to as the Clunk due to the sound made by the nose gear retracting after takeoff, while also receiving the moniker of the Lead Sled because of its heavy controls and modest agility, though its strengths in radar tracking, high-altitude stability, and twin-engine safety made it an ideal platform for the demanding role of Arctic and continental air defense. As international tensions mounted, Canada reinforced its commitment to NATO by deploying 4 CF-100 squadrons to Europe between 1956 and 1962, with these units operating under NATO's One Air Division, replacing Canadair's Sabre squadrons to provide round-the-clock all-weather coverage over Western Europe, with aircraft stationed overseas receiving a distinctive British-style camouflage pattern of dark sea grey and green on the upper surfaces, with light sea grey underneath, while those remaining in North America typically retained a bare metal finish. In the early 1950s, the United States Air Force also considered the CF-100 as part of an urgent search for a jet-powered all-weather interdiction aircraft during the Korean War, with the Canuck being evaluated alongside the English electric Canberra, but it failed to meet US requirements for range and payload, and thus the Canberra was selected and eventually evolved into the Martin B-57 for American use. On July 28, 1957, the Belgian government announced its selection of the CF-100 as its first all-weather fighter, choosing it over several European and American competitors, with a total of 54 aircraft being ordered, though only 53 were ultimately delivered, the first group of Belgian CF-100s being ferried to Méréville in France during December 1957 by RCAF pilots, and then transferred to Beauchamp Air Base, where they served with the first all-weather wing, operating in 11, 349 and 350 squadrons, and would remain in frontline Belgian service until 1964, when they were replaced by the Lockheed F-104G Starfighter. The Canuck's long service was not without tragedy, as several fatal accidents occurred during its operational history, starting on August 11, 1953, when a CF-100 crashed into residential homes in Longueuil, Quebec, killing both crew and 7 civilians, including 5 young children, while another accident on May 15, 1956, saw a CF-100 strike a convent in Orleans, Ontario, claiming the lives of both crew members and 13 civilians. In August 1958, 2 CF-100s collided over RCAF station Gostincon in France, with one aircraft crashing into the base hospital, killing 3 crew members and 2 people on the ground, with additional injuries sustained by the hospital staff, while a further accident in December 1960 involved a night training exercise near Val d'Or, Quebec, where 2 Canucks collided mid-air, killing 4 aircrew. By the late 1950s, the Canadian government had initiated development of a successor to the CF-100, known as the Advanced Supersonic CF-105 Arrow, which had been designed to push the limits of speed, altitude and weaponry, and thus represented the next leap in Canadian aerospace ambition. However, despite promising test results, the Arrow program was abruptly cancelled in 1959 due to mounting costs and shifting defence priorities, and with no Canadian-designed replacement, the RCAF transitioned instead to the American-built McDonnell CF-101 Voodoo beginning in 1962. Despite losing its role as a frontline interceptor, the CF-100 did not disappear from RCAF operations, with numerous aircraft, especially those of the Mark V variant, being adapted for secondary roles, including electronic warfare training, radar calibration, and aerial reconnaissance, with these aircraft being stripped of their gun packs and fitted with electronic countermeasures systems, such as radar jammers and chaff dispensers. 414 Squadron, based at CFV North Bay, continued to operate the Canuck in these capabilities until its final retirement from service in 1981, with the very last military flight of a CF-100 taking place on February 10, 1982, when aircraft 100785 completed a ferry flight to the National Aviation Museum in Ottawa, with this aircraft having been given a special gloss black paint scheme with lightning bolts, a tribute to the original prototype's livery. In conclusion, the CF-100 was one of the few jet-powered all-weather interceptors of its era that was both designed and built in Canada, entering service when most NATO countries were still operating piston-engined or early jet aircraft, and proved itself a robust machine well suited to the demanding job of radar interception in poor weather and at night. However, the CF-100 was also a product of compromise, with its straight thick wing limiting its transonic performance and agility, while compared to the sleek swept-wing fighters emerging from the United States and the Soviet Union, it looked conservative and was technically outpaced by the mid to late 1950s, and by the time advanced variants like the CF-100 Mark IV and Mark V were being produced, it was already becoming clear that the airframe could not keep up with emerging threats, such as Soviet jet bombers or the advent of Mark II fighters. Therefore, while the CF-100 was certainly not flawed in a way that made it unfit for service, it was ultimately a transitional aircraft, proving itself to be very good at what it was designed to do, but not future-proof, and thus served Canada's strategic needs well during a critical period, but its design also underscored the need for more advanced solutions, leading directly to the push for the much more ambitious CF-105 Arrow.